Okay, so this is an update to creating a solid model using Polydata. My last one had some bugs in it, and I did a lot of them using parasolid techniques. This is with Polydata techniques. So I've loaded my groups here. Um, the aorta group, as you can see, currently shown, and the right iliac will be shown in a second here. I gotta select my current path. I'm going to go with the right iliac. And there's our 2D reslices. Make sure segmentation is checked. Okay, so what I'm doing here is I'm creating a path. I already have a path down the right iliac. I'm creating a segmentation down it. What you have to do is create smaller. As you can see, the circle that I'm creating inside of the aorta is smaller, and that's so there's no overlap. And this will just save you some time, so you don't have to edit it down in further steps, because you're not going to get it the exact same size, but you will if you make it smaller and then you make it the right size coming out. It'll be right. And then when the model is made, won't take the smaller one into account. It'll just merge the two of them together. And so now I'm just continuing to create my segmentation. This is one of my last ones. It's still inside that aorta segmentation. And as see, still smaller. And then we're going to just continue to move out until, and see, that's now we're just getting outside of the split. And from this point now, you can go ahead and do threshold. And it didn't work for me. You have to just keep moving down until threshold's going to work. So this is just a demonstration. See, you got to go well past it. So what you're going to have to do on these early ones is do manual, which is what I ended up doing. And it's still even in the 40s, but just as a demonstration, because you're still like pretty close. You're still on the split there. You haven't quite gotten on your own. So what you're going to have to do for all these first ones is do manual. So that's what I did a manual. Notice this is all going into my right iliac test group. I already have a right iliac group that I did before this video, but just for instructional purposes, I made this right iliac test group. And this is a similar manner as I made my my right iliac group. And just to show you, once you get to a certain point, you can just do threshold all the way down, 74, and then segment the current position, and you see it finds it pretty well, and you add that current position to group. And then you can just keep going. I'm in the 80s, segment current position, add current position to group, and then you can just go all the way down to the end of the branch. And that's what I'm doing here. This was just a pretty rough segmentation, and the surface wasn't very exact because I used pretty big gaps in between each value. So I'm just going to go ahead and I'm going to delete this surface. Yep. So we're going to delete that test surface. That was just for instructional purposes to see what it looked like. And this is my actual group, so I'll go ahead and show. This is the one I made before the video doing a similar technique. And this one was a little more precise. I made less gaps in between each value. Or smaller gaps, that is. And so in order to use these two surfaces in our model, the aorta and the right iliac, you have to go to Model Operations, Use Surface. And then you Click on Polydata, test model. So I had already done this before the video as well. You would have said create pre-op solid model. Um, you want to not display the surface so you can visualize your model entirely. So there's our model. The red is our model. The blue was just our surfaces. I'm not displaying those. So now this is our pre-op solid model that we created with Polydata. And if you want to do it again, um, this is how you would do it. You got to make sure when you do this that both are selected, highlighted, and both are used in the model. You have the used in model checked. So this is our test 2, I think I called it. And you'll get that pop-up, number of free edges 0, number of bad edges 0, which means it's all good. And then you can round at it. So there's our test 2. I'm going to go ahead and use our test model that I already worked with. No particular reason, they're exactly the same, but if you want to delete the model, you go to Model Operations. Okay, so this is just showing in your model what you can do with the keys. So if you put your cursor in there and press W, you're going to get like these crosshairs. It'll make it a little easier to see inside. It's not probably, and then you press S to get it back to solid. If you press E in this function, you're going to get a bunch of triangle cells, and then you go back S to get it back to where you want. And then if you press C, I believe it is, yep, C, you're going to get you're going to be able to pick the cells individually. So C, you just hover your cursor over it, you hit C, and then you get the individual cells themselves. And then P is to pick the model and make it easier to visualize. So you hover over it, you press P, and it becomes this like fluorescent yellow. So here's our model. And I'm going to show you how to change the name. So you come over here to surface name. It's currently cap aorta. I think I changed it to inflow aorta. It's really just a preference thing, an organizational thing. I think I changed it back to cap aorta afterwards. So not a big deal. Anyway, though, now we're going to get into smoothing. And so you can look at that junction there, and it's not that smooth. What's good is we have 3 caps, the cap of the top aorta, the cap of the bottom left aorta, and then the bottom right. There's no cap inside that junction, which is good. So what you want to do is go ahead and select the 2 surfaces that you want and go to local ops. And so you highlight both of them, and then you're going to go add faces. And that's down at the bottom there under local region selection, and you should get that pop up, the faces to 1 model face ID. And then you can just come down and go ahead, and so you can locally decimate, and so it's gonna it smoothed it a little bit. Laplacian smooth can have some pretty significant effects, so you want to work between 0.01 and 0.05. I think I changed it to 0.03 or 0.05, one of the two here, and it made it very smooth, got rid of a lot of bumps. Constrain smooth, you want to locally constrain smooth, you want to work between 0.01 and 0.1, oh sorry, 0.1 and 1 is where you want to work between. So I made it 0.3 locally constrained smooth. I'm just kind of giving you an idea. You can do local subdivisions, and all of these will smooth and alter the surfaces that you're working on. So if you use global ops, it has the exact same effects: decimate, Laplacian smooth, butterfly subdivision. They're all similar, they all smooth it, But the thing is, you see that there's only the test model under there. There's no plus. I can't see all of my faces. What I've noticed is if I use one of these functions, say I decimate the surface, which is what I did there, everything gets merged. But there is an undo function, which I'll highlight here. So with that undo function, I went back, and you can see my test model is back, and I can see all of my faces again. So maybe if you wanted to merge it all into one for some reason, maybe at the end, it's good to use the global ops. But I stuck to local ops for the most part in this tutorial. Centerline extraction was the one thing I couldn't figure out, and I'm marking as something to troubleshoot here. So you should say you click on centerline extraction, extract center lines, and you hit OK, and then you hit Enter. You highlight all of your faces and hit Enter, and it should give you like an opaque model and your center lines through it. Unfortunately, when I hit Enter after highlighting all of them, I got error, no IDs found. And so that's something that I'm marking here and is to be solved. I will address it in the next video. So if you want to save your model, you go to File, Input, Output, Save Model. And I already had a test model, so I'm calling this test model smoothed. And then you just save it in the correct folder so you can work with it in the future.